go. Make sure it's recording the audio too, because sometimes I forget to set that one up correctly. This time it is set up correctly. All right, so this is your homework. This was your homework assignment. It's due today in the morning, and it's a little bit more tricky than the other ones, because it does involve the passing of parameters, and that's the focus of last Friday as well as today. Today we'll move on and actually talk about more concepts related to subroutines. But first we have to get this one done so that we know how to do, how to use parameters and the mechanisms of parameters. So let me open this part up as the trace window. So the precondition is really easy to do because we do not have any global variables. There are no global variables whatsoever in this program, which is good because that's what we wanted to accomplish in the first place, is to get rid of all global variables. So in this case, we start with a precondition that really has nothing to state because there are no global variables to say anything about the precondition. And then we start execution on line 16 because line 16 is the first line that is outside of any definition of subroutines. Okay. Because everything from line 1 all the way up to line 15, they are all parts of the definition of either of the two subroutines. On line 16, when we invoke stub, we have to do the two things that we normally have to do. The first thing is to allocate a column for return line number, and then the second thing is to allocate additional columns for parameters and local variables. In this case, stub does not have any parameters, but it does have one local variable I, and any local variable has to start with a value that is unknown. So that's how we set up column D, which is our local variable. This column will become a lot more important later on, but at this point, it is just a column with an unknown value. The return line number is post, because line 16 is already the last line in the pseudocode, so when the subroutine stub is done, it has to go back here, but there's nothing else to do because it will go to the post line. After we set up these two columns and remember where we're supposed to go back to, then we go into the subroutine that we're invoking. In this case, it is stub. We don't track line 11 or line 12 because they really do not have any actions associated. So we go to line 13 as the first line that we track. Line 13 is in return going to invoke another subroutine. This time it is factorial. So we have to allocate additional columns. The first one is for return line number. Then we need one for each parameter. One is n and the other one is r. The return line number is easy to figure out because the invoke is on line 13. So logically, line 14 logically follows line 13. As a result, return line number is 14. N is a little bit tricky. Well, this time it's not tricky. It gets more tricky when we get into factorial. But at this point, it's not tricky because according to the invocation, we use a value of 2 to pass by value to n. So n as a by value parameter starts with a value of 2. R is passed by reference. We know it is passed by reference by two indicators. The first indicator is on the invoke line itself because we use I to specify R. But you can see this is a double-sided arrow. In this class, in cisp300, I use a double-sided arrow to indicate that it is passed by reference. When you go to a C class or C++ class, there will be no visual clue that you're passing something by reference. Okay, then you have to look at the subroutine, which is your second clue that we are passing by reference to R. But in this class, I make it very visual that we know that we are passing it by reference. When you pass something by reference, the parameter becomes an alias of whatever was used to specify it. In this case, I use the local variable I of stub, which is column D, to specify parameter R of factorial. So that means on this column here, in column G, I have to say R is an alias of column D. Are there any questions at this point? Because this is how we use passing by reference. The parameter itself does not store a value. Instead, it tells the subroutine where to find the original item. Is that okay so far? Okay. Now once we set up these columns, we go into the subroutine. The first line in the subroutine fact that we want to execute is on line 4. So here we continue execution on line 4. Line 4 is asking the question, is n greater than 0? The answer is true because n has a value of 2 at this point. Then we go into the then portion starting on line 5. Line 5 is going to invoke factorial again. So we have to set up everything again this time. And what I'll do is I'll use this little trick here so that we can see a little bit better how everything is set up. Doesn't want to move. No, okay. So I'm splitting the screen into 2 halves so I can scroll one side and not scroll the other side. So this way we can keep track of comments and also line number while we scroll the other side to show the new context. We are now executing on line 5. This is an invocation. The invocation will do exactly the same thing as before. We have to set up the same 3 columns. Return line number, n, and r. So the question is, what do we use to fill up these columns? Return line number is easy because this time we are invoking on line 5. Line 6 is the line that is logically following line 5, so the return line number is just line 6. That's the easy one. N is a little bit more confusing because we have n minus 1 to specify the value of n. Now, if you look at the arrow, then you know that information is going from left to right. So that means the end of the left-hand side is referring to the end of the current invocation, not the invocation that we are trying to set up. Can anyone tell me what is the column of the end that is of the current invocation?
F.
Column F, very good. So 2 minus 1 is 1. I have the value now, but where am I going to copy the value to? I'm passing it by value to another n, but this n belongs to the invocation that I am setting up right now. So which column is that n?
Column I.
Column I, very good. So column I is now getting a value of 1 because it is 2 minus 1. R is passed by reference to me, and I'm going to pass it by reference to factorial again. Remember last time we said something about a reference cannot be an alias of an alias? So what we are going to do is to pass the alias along, which means this R here is also known as column D. It is not an alias of column G. Are there any questions about this part? Nope. Okay. So now we move the context over a little bit so that we can focus on just this part here. And once we set up the 3 columns, we go into the subroutine starting on the first line that has any action, which is line 4 again. So on line 4, we ask the same question, n is greater than 0. It's still true because n has a value of 1. Yes?
In my tests for this, would it be best, under circumstances of R, would it be best to use your AKA column D, like to be more specific on what columns you want reference to? Because what I put was reference R, and that's kind of ambiguous since there's multiple cases of R.
Well, it cannot be also known as R. You have to refer all the way back to the I of stub. Because what you did was you created an alias of an alias. Because every single R is an alias already. So what you did was an alias of an alias. You have to refer all the way back to the original column that actually stores the value. Now that we know that the condition of line 4 is true, we go to line 5 again, and we will do almost exactly the same thing. So this time I'll copy it, including the content of those columns, because only one of these columns need to be changed. It has to do with n. Okay, so if I display both of these, we are using n minus 1, and that n refers to this n here, which is column I, to pass by value to this n, which is column L. 1 minus 1 is 0, so that's why this new n will get a value of 0. We pass R to R, but they are both the original R on the left-hand side is passed by reference to me, and I'm just passing the reference along to the R of the new invocation of factorial. So that's why this R is also known as column D. Every single R, there are 3 R's in this trace up to this point. Every single one of them is a reference to the original item, which is column D. And once we set up the 3 columns, K, L, and M, we continue execution in the subroutine that we are invoking on line 4. But this time on line 4, n is greater than 0 is false. Because n is 0 already, 0 is greater than 0 is false. We go to the else, which is on line 8. All line 8 is going to do is to store a 1 into R. But we cannot change this column. Column M cannot be changed because all it is an alias of another column. That's why we have to go all the way back to column D, which is what R refers to, and change column D, which is also known as local variable I of stub, and change that to 1. Is that okay so far? That's the tricky part.
Yeah.
This is the tricky part. When you change a parameter passed by reference, you don't change the parameter, you change what it is referring to. Okay, let me just show the entire screen a little bit better this way. Okay, column C is not really important, so I'm going to hide column C for the time being. This is the trace that we have so far, and line 8 is saying I want to store a value of 1 into R. R is column M at this point. It is an alias of column D. I cannot change this line here. I cannot change this cell because you don't change the value of a passed by reference parameter. You have to change whatever it refers to. And since it refers to column D is the one that gets updated. Are we doing okay so far? Basically, column M, or parameter R, is a little slip of paper with a call number on it. And my instruction is to say, oh, clean up the book that is referred to by the call number. So you don't clean up the little slip of paper that has a call number. You have to check out, you have to go to the library, go to the original book, which in this case is column D, and clean that one up. And that's why the change occurs in column D and not in column M. Are there any questions? I mean, is that okay or not? This is really the whole concept of passing by reference. Is the parameter is nothing more than an alias of the original item. Are we good to go? Okay. Okay. Maybe after we finish the whole trace, we can just kind of take a look at the overall picture again. Then it'll be much more clear as to why we have to do it by passing by reference. Okay. After line 8, we have to move on to outside of the conditional statement. So let's go take a look. We are at line 8 at this point. After line 8, we have to go to line 10. Line 10 is end define sub. Okay. End define sub doesn't really have that much to do. It has to look up the most recently defined return line number, which tells us we have to go back to line 6. So here we go back to line 6. And in addition, on line 10, we also have to clean up all the columns that we have set up for this particular invocation. Some people have told me that they could not do the merge cell thing. So instead of doing the merge cell thing, I will do the other thing, which is also referred to in the notes, is basically changing the font so that it has a strikeout mark here. So this is another way to indicate those columns are now deallocated. This is the new way of doing things. If you read the notes, this is how I indicate columns are now deallocated. Are there any questions at this point? Now we're back to line 6. What does line 6 do? Let's go check out the code. Line 6 says I want to multiply R and N and then store the result back into R. R times N goes back to R. My current context is established by column H, I, and J. So when I refer to N, I'm actually referring to column I, which has a value of 1. R is passed by reference. It is also known as column D. So whenever I refer to R, I'm actually referring to column D, which also has a value of 1. 1 times 1 is 1, and I store the 1 back into R. Once again, column J, parameter R is a reference to column D. So when I update R, I am actually updating whatever it is an alias of. So in this case, I'm updating column D again. It has a value of 1 again. Okay. Then we get out of the conditional statement. We get to line 10. Line 10 is going to do exactly the same thing as last time. We find out what is the return line number. It tells us we have to go back to line 6. Okay, fine. We go back to line 6. Then we have to deallocate all 3 columns. And once again, the allocated columns, I just copy and paste the 3 columns header. Then we go to the cells, use a strike through symbol, and to indicate they're deallocated. If you put a whole bunch of X's there, that's fine too, as long as the X's cover all 3 columns, it's the same thing. Okay? And since we're back to line 6, we have to perform what line 6 does. Line 6 is n times r goes back to r. So this time we have to look up what is n. My current n is column F, and this n has a value of 2. R is column D. R is a reference to column D, which has a value of 1. 2 times 1 is 2, and we store the 2 into R. Once again, R is passed by reference. It refers to column D. So this time column D is updated to a value of 2. Then we move out of the conditional statement. We get to line 10, and line 10 will do its usual thing. We look up the return line number. It tells us we have to continue execution on line 14. Then we clean up these 3 columns. We'll deallocate the 3 columns and mark those as deallocated at this point. And now we're back to line 14. Line 14 does not really do anything that particular spectacular. All it does is to print the value of I. And at this point, I is column D. So what I'll do is just print the value of I, which is 2. Then we go to line 15. Line 15 is end of the subroutine for stub. So what we do is we look up the return line number, which is post, and say this is where we'll go next. But before we go there, we also have to remember to clean up the 2 columns and indicate that these 2 columns are now deallocated. And then we continue execution at post, and the whole thing is done. Yep.
I have a question. If I write in on line 14, print I in parentheses with the 2, it's okay or not?
If you put parentheses around it, that's fine, because all I need to know is whether do you know what you're supposed to print. Yep. But the most important part of this homework assignment, let me just highlight what I think is the most important parts. Of minor importance, okay, I wouldn't say that's the most important part. Of minor importance are these 2 cells, because I want to make sure that people do not create reference to references, okay, alias of aliases. So what I'll do is I'll just kind of highlight these, but with a fairly light color to indicate that it is important, but I don't think it's a big problem. Okay, most people will understand that an alias has to be an alias of the original item and not an alias of an alias. In other words, column J is not supposed to be an alias of column G, and column M is not supposed to be an alias of column J. They are all supposed to be aliases of the original item, which is column D. Okay? I'm being very picky here because this is exactly how the program does it. Okay? When you write a program like this is exactly how internally the program is going to work. Now, why do we care how the program is going to work internally? Well, that's because many of you will have to take cisp300, and then we'll see this stuff again, and that's very important. The second thing, which is even more important, is when we store something into R, you do not change column M in this case. When we store 1 into R, we have to store it over here. That is the most important part of passing by reference, is you don't store it into the parameter, you store it to wherever the parameter refers to. In this case, it is column D. So I would highlight these 3 with a more obvious color because they are actually the more important part of this trace. So when you look at this trace again, I hope the color coding would kind of help indicate which parts of the trace are the most important parts. The rest of the trace are basically just the same stuff that we have already dealt with before, invoking a subroutine, returning from a subroutine, local variables, and passing by value. Those things are not really that tricky. But the highlighted portion of this particular trace, they are the most tricky parts of passing by reference. Are we doing okay so far with this trace so far? Okay. Are there any questions about passing by reference at this point? No questions? Okay. So I will make sure I save this file. Okay. This is going to be saved to today's folder. So when I upload the zip file of today's folder, this will be one of the files in that folder. And it may not be a bad idea to trace this program again. If you think that you might have done it wrong the first time, when you turn in the homework assignment, don't worry. The homework assignments, do not really carry a lot of points for your final grade. If you just, have certain points deducted a few times, it's not a big deal. You just want to make sure that you understand the concept so that in the exam, you will get it right. Okay, so the whole idea is if you think that you might have done it incorrectly, don't study my solution yet, okay, because we have already seen it once. What you want to do is to use, sheet 3 to trace it again. Just go through the trace one more time and then compare your new trace to my trace that I just did today and make sure that it is there, those two are consistent. Okay. So now we'll move on and talk about other concepts of subroutines. I'm going to start a new spreadsheet before I close the other one because I'm going to need a new spreadsheet too. I'm waiting for the browser to scroll. And the browser is taking a nap. Come on. You can do it. And it's taking a nap again. Alrighty. Okay, so we are basically done. Okay, I want to show you guys where I'm, which part of the notes I am talking about at this point. I'm mostly talking about, using the updated material on subroutines, and this is the updated notes, and it uses a better way to explain things compared to the other notes. It's not wrong to read the other parts. It's just that this one is more consistent with how I teach the class now, so it's a better way to do things. We are going to talk about return values. But before we go there, are there any questions about passing by value, passing by reference, or local variables before we go to returning values? No questions? Okay. If I have to ask you, what is the main purpose of a by-val parameter, how would you classify that? How would you describe the main purpose of a by-val parameter? If I'm working in an office, which is the subroutine, what do you think a by-val parameter will be equivalent to? It's my in tray. Okay, that's my in tray so that someone can pass information to me. But it's not a good out tray, is it? Because a by-val parameter has its own value, which is a copy of the original. As a subroutine, I can mess up, I can shred the original. I can shred whatever you pass when you put onto the in tray, but it's not going to affect anything that you can see, because when you, which is the code that is invoking the subroutine that is me, you made a copy of the original before you put it onto the in tray. In other words, whatever you put onto the in tray is something that is disposable from your perspective. And as a subroutine, when I am done with whatever I'm supposed to do, I will put that into the shredder anyway. Okay? So a by-val parameter is very useful as an input into a subroutine, but it's not very useful for passing results back out of a subroutine. And that's why we have by-reference parameters. Because with a by-reference parameter, a subroutine can now suddenly, without the use of global variables, change the variable or by-val parameter that belongs to somebody else. So it is one way to pass a result back out to somebody else. Is that making any sense so far? Is that okay? Okay. So by-reference is very useful, but it's not very concise. Okay, that's the problem with by-reference parameters. It accomplishes all the things that we want to accomplish by passing the result back out to somebody else, but that somebody else needs to have a place to store that value. In other words, if I want to do, okay, let me just give you an example that will make this kind of more clear. And let's see. Oh, I'll just use a spreadsheet to do it right now. Okay. So if I want to do something, as dumb as this, okay, I want to write a subroutine that can add two things and then pass the result back out. Well, when you add two things, you need to pass by value the first thing that you want to add, by val the second thing you want to add, and then by reference the result of adding those two things. And the actual subroutine is quite easy. Result is x plus y, and define sub. And I can do the same thing with multiplication. By val x, by val y, and then we say by reference result. And this time result is x times y, and define sub. So now obviously there's a big question of why am I doing this? I mean, we have addition and multiplication already. Why do I want to define subroutines to perform addition and multiplication? The answer is quite simple. Okay, even though in this case I'm just using the addition of integers and the multiplication of integers, when you perform, say, scientific calculations, you might be adding two vectors together. You may be adding two complex numbers together. You may be adding two things that are not just scalars or integers or real numbers together. So that means, addition is really just an operator that means certain things in a particular, environment. It may not be as simple as just, adding x and y. Okay? So I want to be able to, do stuff, as what I usually do with numbers, which is, passing the value of passing the sum of an addition to as a part of the product, and so on and so forth. Okay. So now that I have these two, how would I do something like this? Okay, outside of the two subroutines, how would I do something like I want to compute z to be 1 plus 2, and then the whole thing times 5. Now, obviously, we already know what is 1 plus 2, the whole thing times 5, it is 15. But let's just say that this is the calculation that I want to perform, but I want to use the subroutines that I have here to perform this calculation. Obviously, but at this point, let's just say that I don't even want to store the result somewhere. I just want to print it out. I just want to print what is the result of 1 plus 2, the whole thing times 5. Okay, this is what I want to do. But in order to use these two subroutines to accomplish what I want to do, I need to have a global variable. Because without a global variable, or without a variable of some kind, I cannot store the result back so that I can use it again. Is that making any sense? Okay. So the simplest thing I can do here, well, I'll do the obvious one first, and then I'll explain why the obvious one is not really good, and it will actually have problems. So instead of doing z first, I have to first figure out what is 1 plus 2. But in order to do the 1 plus 2 using the subroutine add, I need to pass by reference the result, which means I need a place to store the result. So for that purpose, let's just say that I have a global variable called sum. Okay? And this is what I will do. I will say invoke add. I will use 1 to specify x. I use 2 to specify y. And then I will use my global variable sum to specify result. so that the result will actually be stored in the variable sum. In the next one, I can now invoke multiplication. I can now reuse the variable sum so that it can specify the x of the multiplication, and then I can use 5 as a constant to specify the second number for multiplication, and I will also need another global variable product to store the result. When it is all done, then I can print the product. Okay, so I can now print product to show the actual value of 1 plus 2, the whole thing times 5, in order to accomplish that. So are there any questions about this part of the program, what I'm trying to do and why I have to have global variables, sum and product? Is that okay so far? Yep.
So we don't have to call those two global variables in like the beginning of the code at all? Like we can set them up like right in...
You don't need to set them up because they will be initialized when you perform the add and multiplication.
Okay.
They just need to be allocated, but they don't need to have any specific values because those values will be overwritten before the variables are read.
Can this program be written without global variables also, or is there?
Well, given the mechanisms that we have, you can do it without global variables, but you still need variables of some kind. Okay, I can show you how we can do it without global variables. You just have to make a stub function or make a stub subroutine. Just like with the homework assignment, you have to define a stub subroutine, and then inside the stub subroutine, then you have to say local sum and local product. So this is one way to avoid the use of global variables, but you're still allocating variables just for the purpose of being able to use those subroutines. So this works okay, but when you invoke stub, you're still creating these additional local variables in order so that you can use add and multiply. Now, what is the problem here? There are several problems with this approach. The first problem is, what if I use the wrong variable when I invoke sum or mult? The compiler doesn't know. Okay? In other words, if I supply sum again here, and I choose to print product, then the program is not going to work. Okay? It will not display the correct result. Or if I choose to use product here by accident, then the program is not going to work either. In other words, the way it is set up right now will work. It will work just fine. It utilizes a pass by reference parameter in order to pass the result of calculation back out to the invoking code. But it does leave a lot of room for manual error. Okay, it's just a lot of accidents waiting to happen, which is not good. So that's why we have to talk about returning values, because let's also I'm just going to put it here, and say, what is the difference between that and this? If you compare these lines of code to this line here, what is the main difference? This one does not have the use of any global or local variables. Because what are we doing here? We perform the addition first, 1 plus 2, which is 3. But we use the result of the addition immediately, and then we use the calculation. We use that to calculate the product of 3 and 5. What happens after we compute 3 times 5? Once again, we use that result right away to print it out. We don't have to store it to some variable before we print it out. Okay. In other words, the difference of the two approaches is not just syntactically one is longer and more cumbersome, but in a more important way. The first approach is bad because it has to store the result into variables first, and then we utilize the variables. In the second approach, we utilize the result right away without having to store it somewhere else. So we want to be able to do something like this with our subroutines. That's the whole idea of why we want to be able to return a value from a subroutine. Are we doing okay so far about the rationale of returning a value? So this means, the infix notation of adding and multiplying, they are already, returning values. It's just that we never look at those as subroutines. Okay. Now this is also a good time to kind of digress a little bit. And let me just use another sheet to do the digression. Okay. Now with what we just saw a little bit earlier, 1 plus 2, the whole thing times 5, this is called the infix notation. This is this is how we were taught to represent, the calculations like this one ever since elementary school. It's called the infix notation because the operator, the addition symbol, and also the multiplication symbol is between the two values that it is supposed to operate on. Is that okay? That's why it's called the infix notation. In programming, there are some programming languages that use a prefix notation. A prefix notation would basically specify the operator first, what do we want to do, and then you have to specify what it is going to operate on. So this will express exactly the same calculation using the prefix notation. The prefix notation is really not hard to understand once you know what it is doing, because for the inner parentheses, it is saying that we want to perform an add operation. But an add operation requires two numbers, so these are the two numbers to add. And then the result of this entire add operation will become the first value that you use for the multiplication, and the second value for the multiplication is the 5. So this is called the prefix notation, which is, putting the operator first, but you still need to rely on parentheses a lot in this case to specify the precedence of operation. Yep.
Why isn't there a comma after the 1?
It's just because this is called a Lisp syntax, and Lisp does not rely on commas to separate items.
So then you would have to have a space.
Yes, correct. You have to use a space to do that. Sorry?
If there's no space, it becomes 12.
Right.
Correct. Yep. Mm-hmm. Yeah, but this is called a Lisp syntax. Lisp, L-I-S-P, stands for list processing. It's a very specialized programming language. Yep.
Are there any other programming languages that actually consider white space like that?
I'm trying to think. I think Lisp is the only one that I know of that would use white space, for. Well, Lisp is kind of strange because it doesn't. It's not a conventional programming language. Everything is a list in Lisp.
Okay.
Your program is a list in Lisp. Your data structure is a list in Lisp. Your arrays are a list in Lisp. So everything is a list in Lisp, and that's why it is also kind of powerful, because the programming environment itself can generate new lists that can be considered as subroutines. So you can basically the program can create additional subroutines for itself, or it can modify existing subroutines that are already in the system. So Lisp is a very interesting programming language from that perspective. Okay. Now we have infix, we have postfix. What else is what is missing here? Excuse me. We have infix, we have prefix. I just told you the answer right there. Postfix, right? So postfix means you have to specify the numbers first, and then you specify what you want to do with those numbers. So in this case, in postfix notation, we will have to say 1, 2 first, and then we specify an add operation. What the add operation will do is to utilize the 1 and the 2, so it will clean those, it will deallocate the space of those two numbers, perform the addition, and then the sum will now be a part of what is stored. Then you specify the 5, and then you perform the multiplication. This is called the postfix notation. The postfix notation is the one that does not require any parentheses. Okay, because the order of operation is simply implied by when do you want to perform the calculation. Does anyone have an old HP calculator? No?
My dad does.
Your dad does? Your dad will be, very proficient at RPN, or this is what we call reversed Polish notation. Okay, it's called RPN.
Yeah, because on this calculator you have to type 1, enter,
Yep.
2,
Plus, and then 5, enter, and 5, and then multiply.
Yeah.
Yep. And your dad can do that without having to write the original, equation on paper first. He can do it all in his head, and I can do the same thing too. Okay, it's really just a matter of which one we are used to, and I'm pretty sure that if they had taught either of the prefix or the postfix notation from elementary school, will be just as proficient with those two representations too. It's just a matter of getting used to it. Yep.
Is there an advantage to using prefix or postfix?
Yes,
over
absolutely. Prefix notation is extremely easy to parse. In other words, if you want your computer to actually perform this operation here, it has to go through a lot of kind of more complex parsing to restructure the symbols and the operators in order to understand, so you want to add 1 and 2 and then multiply the 3 to the 5 and then get the result. Okay, so internal to the computer, internal to Excel or Calc, it is actually fairly complex to reconstruct the order of of the operators and whatnot. Prefix is easy. Prefix is extremely easy to parse because the operator always comes first, and then you have the numbers that you're supposed to process. And the parentheses indicate which one has to be performed first and so on. But it is still more complicated compared to postfix, because postfix has no parentheses. So the parsing of a calculation that is specified in postfix is really, really easy. Okay? You just need a concept of what we call a stack. Okay? Once you have the concept of what we call a stack, it does not require parentheses. The parsing of the last form, which is the postfix notation, is simple. Okay, you can write a very simple program to parse the postfix notation, and that is partially why HP calculators use the postfix notation. It's because they don't want to deal with the complexity of using the infix notation and also the use of parentheses.
So if your program's going to do a lot of calculations, you want to write it in postfix?
They're all equivalent. They're all equivalent. You can transform it from one representation to another one. So these three are basically equivalent. They can do it. They can express exactly the same type of calculations. It's just that from the machine's perspective, from the parsing perspective, the infix is the most difficult to parse. Prefix is easier, and then postfix is like simple. It's a piece of cake to parse it. And that's why HP calculators, in early days, use the postfix notation. It's because it is so easy to parse. It is also the reason why we have the language called PostScript. Okay, does anyone know what is PostScript?
That's what you write at the end of the letter.
Yes.
PS.
Yeah.
Yep. But it is also a programming language used by printers. Okay, I'm not sure how many of you, want to buy, have the experience of buying a printer, and many printers have what they call PostScript emulation. In other words, your computer can send it, PostScript instructions in order to render the graphics on a piece of paper. Okay, you guys don't know what is? Yep, go ahead.
Is that the language or scripting language that Adobe made?
Yes,
Okay.
Adobe made PostScript a long time ago for the
really familiar.
Yeah, for exactly that purpose. Because before you guys remember dot matrix printers, right? I mean, I know most of you are fairly young, but I'm hoping that you still remember, what dot matrix printers are. With a dot matrix printer, most of the calculations are done on the computer itself. So the computer will send all the dot locations to the printer. It's like it will send the dot locations in bands. Okay, because dot matrix printers, I think in the later days they can print like 24 dots, on the same pass. So the computer is responsible to render everything, inside the memory of the computer, figure out exactly where the dots are, and then it will pass or it will transmit, which dots have to be, have dots, have to strike, to the printer, and it will send it, band by band by band by band. Now, when you use a higher resolution printer, you have to change the driver on your computer because now you have more dots per inch. Okay, And that means a lot of the burden is on the computer itself. Every time you change the printer, your computer needs a new driver. Okay? Now PostScript is quite the opposite. The computer will just say, I want to draw a circle in some sort of absolute coordinate, in some sort of universal measuring unit. It's usually in, what is it? It's in points. Okay? It's not in inches, it's not in centimeters, but internal to the printer world, they have their own universal unit of measuring distances. So what the computer would do is to say, okay, I know that you're supposed to use an A4 or letter-sized paper, and this is where I want to draw a circle. Okay, the center of the circle is here, the radius of the circle is this, and the thickness of the circumference is this. And the printer, it will interpret that instruction and actually draw the circle. Now the printer, being the printer itself, understands its own resolution. Okay, I have 300 dots per inch, I have 600 dots per inch, I have 1200 dots per inch. So the printer will now be able to do all the calculations and figure out where the dots are supposed to be without burdening the computer itself. Okay, and that's PostScript. And PostScript later on evolved into PDF. Okay, so PDF is actually a descendant of PostScript, except the purpose has changed a little bit. Instead of asking a printer to render the image of what should be printed, PDF is more intended for a computer screen to display what something should have been printed, so that you can display what it is supposed to be, what is supposed to be printed. So it's actually quite the opposite, because now you can display on screen something that is supposed to be on paper, as opposed to sending the same specification to the printer, so the printer can print it out. Okay, but why do you think the language is called PostScript? It's because it uses postfix notation. And the reason why it uses postfix notation was because in the early days, laser printers have fairly weak processors, and they don't want to have to implement all the other stuff in order to parse infix and also prefix notation. And postfix notation is the easiest one to parse and the easiest one to handle, and that's why they also use the postfix notation. Okay, so just a little bit of history of all these different representations. But as I said, this is more or less a digression, just so that you guys know the different ways of expressing the same calculation. But getting back to our focus here, so what we want to do now is, if I go back to our notes, we are now getting into returning values, or how to return a value from a subroutine. The first thing I'll do is to give you a very simple example first, and then we'll move from there. Okay, so here's another spreadsheet, which is a very simple example of returning a value. Define sub, 6. Okay, and all it does is to return 6, and define sub. And let's just say that we want to make this program really, really simple, so that we can focus on the only one concept that we want to talk about. So we have one global variable called x, and we'll say we'll use x to store the return value of invoke 6. Now, most of you looking at the code like this already know what the program will do. The program will simply initialize the global variable x to 6. The question is, how do we track it? How do we trace a program like this? So here we have a new window to perform the trace. And this is the focus of this class. It's not really what the program does, because it's quite obvious what it is going to do. But the question is, how do we track it this time? Okay, so we have line number as usual. And then we have one global variable x. I know I'm not supposed to use global variables, but since we want to focus on just the concept of returning a value, this is what I'll do. The precondition is, since x is just a global variable, we cannot make any assumptions of its original value. So it will just be a question mark. And the first line that we execute, we do something, is on line 4. And right away we have a problem. Because how do I know what I'm supposed to use to update x with? Now, in this case, it's easy because the subroutine 6 is just returning a value of exactly 6. But what if this is a complicated subroutine? We don't know what it's going to return. I mean, we cannot just eyeball the algorithm and say it's going to return this value. We cannot do that. So that means before the assignment operation can happen, we have to invoke the subroutine. Is that okay so far? Okay. So, okay, we know how to invoke a subroutine. I mean, that's not something that we have trouble with. We say return line number, and then we say, oh, we have a problem here, don't we? Because when you use return line number, you can either say post, because there are no additional lines after line 4, or you can say line 4. Either one is wrong. Okay, let's say let's just explore why they're wrong. If I say post, and subroutine 6 is all done, it returns a value of 6. However we do it, it doesn't even matter. Then it will go to post. What happened to my assignment operation that is not done yet? It won't be done. Okay, if I go all straight through post, then I'm not going to finish the operation on line 4. So that's not right. If I say line 4, I have a problem as well. Because if I say go back to line 4 after after the subroutine 6 is done, then I'll go back to line 4 and start from the beginning of line 4 again, which means I'm going to invoke the subroutine and then go back to line 4 and then start all over again. So once again, then that's not what I want to do. So that's why when you have a subroutine that returns a value, you have to change the representation to something that is a little bit more specific. It is called return info in this class. These terms are all somewhat artificial that I introduced in this class. They won't be referred to in your cisp300 class anymore. But it is important for us to understand how do we remember where we're supposed to go back to and what else do we have to do on that line. So in this case, the return info will still say that we have to go back to line 4. But in addition to just indicating the line number, we also spell out the rest of that line that we are supposed to do. But we also have to say what is the role of the subroutine invocation in the execution of line 4. So the return info looks like this. 4: is simply saying that we are supposed to go back to line 4. X, and then we have the left arrow, represents what else do we have to do on that line. The question marks with parentheses around it is a placeholder. Okay, it's a placeholder to basically say, okay, I'm reserving a space here for the return value. When I have a return value specified, it goes here. Okay, so the question mark is a placeholder so that we can specify whatever the subroutine is returning, to the question mark, the place that is being held by the question mark. Everything else is the same. Okay, we still have to allocate additional columns if we had local variables or parameters. In this case, we don't have any of those, so we're basically all done, with setting up the return info. In this case, we then continue execution in the subroutine starting on line 2. When you execute a return statement, you are going to substitute the question mark with whatever the question mark is supposed to be, okay? Because that's the return value. So what you do is you copy and paste the return info cell, and then what you have to do is to replace the question mark with the value that you're returning. That's the effect of executing a return statement, is to replace the question mark with a specific value. Okay, it has to be specific. It cannot be X, cannot be Y. It has to be a particular number. Okay, but you do not execute line 4 at this point. Then we move on to line 3, which is the end of the subroutine, and we do exactly the same thing as always. We just go to the return info cell this time to remind us where we're supposed to go. We're supposed to go back to line 4, and then we deallocate that particular column. So I'm just changing my style here to use the new way of doing things. You guys can pick whichever way you want to use to indicate that columns are deallocated. I'm just making this more consistent with my notes. Okay, now we're back to line 4, but line 4 is no longer, okay, let me use the pointer here. Line 4 is no longer as it is described in the pseudocode here. Line 4 is now looking more like this, because we have just resolved the unknown, the question mark, that is taking the place of the return value of the subroutine. So now we know exactly how to complete the assignment operation, because we know that we are supposed to update the variable X with a value of 6. Exactly. So now the effect of line 4 is to store a 6 into variable x, and then we're done. So are we doing okay with this concept? It's not really, it's orthogonal, in a way it's orthogonal to all the other concepts that we have talked about so far, and yet this is a very, very important concept in terms of writing and using subroutines.
What do you mean by orthogonal?
Orthogonal means, it cannot be, the effect cannot be done by existing concepts that we have talked about so far.
Okay.
Sorry. It's my linear algebra talking. Yep.
Why do you put 6 on line 4 if you write everything in a subroutine?
Why do I put, okay, which row are you referring to in the trace? The row numbers are from 1 to 8. Which row are we looking at?
7 and 5.
Okay, row 7 and row 5, like that? Okay. Okay, row 5 is the execution of the return statement. Okay, when you execute a return statement, all you're doing is to specify what the question mark is supposed to be. You use the value that you're returning to specify what the question mark is supposed to be. And that's exactly what we did on row 5, because we copy and paste the return info cell, and then we change the question mark to the value that you're returning. But we do not perform that operation here. This is the wrong time to do it. Okay? We're just resolving. We're just resolving what the question mark is supposed to be, but this is not the time to execute it. We still have to finish up the subroutine 6, because we have to go to line 3 to end the execution of the subroutine itself. Now that will, and when we execute line 3, we look up the return info cell and we know where we are supposed to go, which is on line 4. But at the same time, we already, by the time we get to line 4, we also know that line 4 does not look like this anymore, because we already know what is the result of invoke 6. And therefore, we know that we are supposed to update variable x with a value of 6 in this case.
So it's different than you explained in the last lesson that whatever you give to the subroutine, it's gonna shred.
It is different from everything that we have talked about so far. This is a new concept. We cannot replicate this effect using any of the existing concepts that we have done so far. Yep.
Is there a statement in C that does the same operation?
It is also called just return.
Just return? Okay.
Yep. Mm-hmm. Any other questions about this? The trick is to understand that if you have return info and you return to the line that you're supposed to return to, when you are back to that line, you have to kind of go back to return info and say that line now looks like this. That is the trick of using return values. Yep.
Yeah, I get the concept. I just think some of the confusion was coming from before when we'd on a red line number, after you shred it, the info's gone. So
right.
Pretty much we closed it out, but the info's still there. If we had assigned 4.
Well,
so
it's
got closed out.
It's basically just that we have resolved what the invocation is, so that we can continue with the rest of the operations on that line.
Yeah.
Yep.
Just how it's written, just is kind of confusing based off what we were talking before.
Right. But if you prefer, you can just copy this, over here before you continue execution, so you can actually see the entire line, in the line number, column. But this is, just another way to represent the same thing. Okay. And are there any other questions about this? Are we ready for a slightly more complex example? I'm just building up the examples, in kind of increasing difficulty, and this is the simplest one. This is this is the simplest example that I can use that has a return value, because we're returning just a constant. There's no calculation involved. There are no parameters involved, and there's only one level of subroutine invocation. So let me just save this one first, and I'll just say simple return value. And then we'll go ahead and start with another one. And after this example, we'll take a 10-minute break, and then we'll continue with even more complex examples. Before the end of this class, we'll talk about how to use the same concept and apply it to factorial, and that will be your next homework assignment. And I'm hoping that he won't miss it, because he just left early. He had something else to do. All right, let's go ahead and start with the next sample program. And this time I will go back to add. Okay, define sub add, and we'll say by value x, by value y. And this time I return x plus y. I don't need a by reference parameter anymore this time. And go ahead and fix the indentations. Define sub multiplication, by val x, by val y, return x times y. Once again, there are no pass by reference parameters anymore. And then we'll go indentation. There we go. And this time, I want to print the value of 1 plus 3, 1 plus 2, and then the whole thing times 5, just like last time. And the question is, how do we do that? Well, we can say print, and then we know the last operation we have to perform is the multiplication. So that's why we have to put this, as the outside of the whole thing. And let's just do a simple one first. Okay, let's not even try to put the add in. Let's just say that we want to perform, 3 times 5. Okay, just like that. We'll trace this program first, and then we'll make it more complex later, after the break. Sheet 2. We have, we need comments because we have a print statement, but we won't need it until much later. We have line number. We have precondition. Do I have any global variables this time? There are no global variables. Very good. And the first line to execute is the only line that is outside of the definition of any subroutine, which is line 11. Line 11 is going to print something, but I don't know what it's supposed to print. Well, I don't know what it's supposed to print, because what the value is supposed to print is the return value of a subroutine. So I have to invoke the subroutine first to find out what value it is going to return, so that in return I can print that value out. So I have to set up return info, just like last time. But since this time the subroutine I'm invoking also has 2 by value parameters, I will also have to set up column D and column E for these 2 parameters. The parameters are really easy to set up this time, because they all have just constants. So 3 goes to x and 5 goes to y, and the return info tells me where I'm supposed to go back to and what else on that line I have to perform. So in this case, I have to say we're supposed to go back to line 11, but when we go back to line 11, we have to finish up the print operation. The value that we are supposed to print will then be specified by the time I'm done with this subroutine. Are there any questions about row 4 or how I set up the columns? The subroutine is supposed to return a value. The value it will return is indicated by the question mark as a placeholder. It is still the invocation of a subroutine that has 2 parameters. So I still have to set up the 2 parameters, which is column D and column E. Are we doing okay so far? Okay. Because if there are any questions, this is a good time to stop and ask. Yep.
Well, why did you write the add? Because it looks like all we're going to be utilizing is the multi-sub.
Right, because I changed my mind.
Oh, so
I was planning to use the add as a part of the mold. Then I thought, well, maybe we'll do the simple one first, and then we'll do the one
Okay.
that has an add inside the mold.
Okay.
Yeah, so that's why. That's a good question. So right now the add is really just sitting there doing nothing.
Okay.
Yep. Okay, so now we are done with setting up column C to column E. We are ready to go into the subroutine. The subroutine only has one line that is really useful, which is line 4. Line 4 says I want to return the value of x. Oh, excuse me.
Yeah.
Looking at
line
the wrong
9.
subroutine. We're supposed to go to line 9, and we're supposed to return x times y. X is 3, y is 5, x times y is 15. In other words, when we execute line 9, it is returning 15. Now, when you execute the return statement, once again, what are we supposed to do?
Replace the question mark.
Replace the question mark. So you copy and paste, and then you replace the question mark with the value that we're returning. In this case, it is based on the calculation of x times y, which is 15. That's all that you have to do when you execute a return statement. Then we go to line 10, because that's the end of the subroutine. And line 10 says, okay, first look up the return info cell to remind you where we're supposed to go back to. We're supposed to go back to line 11, and by the time we get back to line 11, it will look like this, and not like the original version in the pseudocode. Then once we know that that's what we're supposed to do, then we can go ahead and deallocate column C to column E. Like so. And now we're back to line 11. But once again, it is important to remember when we get back to line 11, it now looks like this, or C5, the cell C5 describes the current state of line 11. And that means I'm ready to print. I know exactly what I'm supposed to print, which is the value of 15. And after line 11, I'm all done. There's nothing else to do. So once again, the key is to use return info to keep track of what else you have to do when you get back to that same line. You can look at this as a more complete version of return line number, because with a return line number that we're used to, it's simply saying the next line. Okay, this is just a more detailed version of a return line number. But when you use any subroutine that has a return value, you have to use return info, because you will go back to the same line again to finish up something that is not done on that line. Okay? Are there any questions about this trace? Because if there are any questions, I want to answer those questions before we take a break, before we forget what the questions are. No questions? Is that okay so far? Okay, so let's go ahead and take a 10-minute break. During the break, if you have any questions, just write it down so that when we come back, we can address those questions before we move forward to a slightly more complicated version of using return values.
When is your office hour?
You mean today?
Well,
I have one today from 11 to 12. Like right after the class, just follow me to my office.
okay.
On a regular day, it's from 9:30 to 10:30 in the morning. Okay. But if you need some other time slot, we can arrange for a different time slot.
No, that'll work. I can do that on a Tuesday
Okay.
or like a Monday or a Wednesday.
Okay.
Because I was sick last week, and so I got really well. So
Okay.
go over the.
Did you have a chance to watch the video?
I watched it, and
It's still not.
yeah,
Okay. It's not
I did
connecting.
not understand. My dad did the program, and I asked him, he couldn't. So,
Yeah, because of the way that I explain things in this class.
yeah.
Yeah. Okay.
Okay.
Yeah, seriously.
So I don't forget exactly. I suppose there must be a timer somewhere in the system.
Yeah.
I have one application, that keeps track of time on the project. So when I switch to a particular project, if I remember to click that thing, it will restart a timer on that project. So it's really great if you're a consultant, so you can keep track of how much time you have spent on a particular job.
So started the recorder for the first part of this.
Oh, that's right. I think we stopped the recorder first and then started again.